Alright, so in our RTS game, today we are going to implement grid snapping feature, which means if you try to place a building in your level, now you can see it somewhat snapped to a invisible grid on your level, right? So previously actually when we are placing our buildings on the level, it smoothly transit in between each and every individual location. But right now, with this grid snapping behavior, you can see it's somewhat aligned, right? Somewhat predetermined sort of a location is there, right? Okay. Uh, so let's see how we can implement this grid snapping feature for our RTS game. Alright, so let's implement grid snapping feature to our game. So we have to go under the blueprints BP building manager, and there let's create a function called grid snapping. Okay, and then we need to get a location. I'll call it as in location, and then as the output value out location. Right, so ideally what I wanted to do is I feed the hit result location to this specific grid snapping function as in location, and it do some calculations over here. After that, as the return value, it returns a grid snap location as the out location, right? And then that out location can be fed over here as the new location of the building to be placed, right? Uh, so let's break this value first, and I'll break this one as well. Oh, I have to make a vector over here. So here we need to snap this x axis as well as the y axis, right? So we don't necessarily need to do grid snapping with respect to the c axis, because this one is just a vertical axis. It's an axis that is perpendicular to our level, right? So we don't need to do a grid snapping on that axis. Instead of that, we need to be aware of the x-axis as well as the y-axis. So I can directly plug the c-axis like this, and for the x and y I have to do some calculations, right? So I'll create a new function called snap plot, right? And in this snap plot I can get the float value. So I'll name it as in float, and as the output I can return out float. And then let's divide this by a float, and I'll promote this to a variable called grid size, and let's assign it to a category called maybe setup. Okay, and this is the size of our grid, right? So for now I'll make it as 50, but later on we can change this value. So if you want, you can tweak these values for a number that is comfortable with your game, or that is compatible with your game, right? And then let's round this float value so it will return an integer. We have to multiply it by this grid size, and we can return this value. Also, this one is not manipulating any global variables. So I just only process and return a new value, right? So therefore we can make it as a pure function. So pure function is basically a function which has no side effects, right? So side effects mean if some function is manipulating a variable, it's not a pure function, right? Because it has a side effect. But in this scenario, it doesn't manipulate any variables. It just internally process and return new value. So therefore I can make it as a pure function. Okay? And that function we can feed it over here to snap our x-axis as well as the y-axis. Okay? I'll move the c value like this. Okay, so this is the function that performs the grid snapping what we require, and that grid snapping should be done on this event peak. I'll make some space over here, and let's use our grid snapping function, and as the in location I'll use this one, and I'll unplug the previous it location instance, and instead of that let's place this out location as the new location of the building to be placed. Okay, so let's compile and save, and let's try simulate our game again. Okay, so I can see a small grid snapping over here, right? You can see it's not smoothly adjusting a location. Instead of that, it has this smaller grid snapping. But I think we have to improve this, or we have to increase this grid snap value. Maybe I'll make it as maybe 200. And let's play it again. Yeah, so now you can see there is grid snapping, right? But I think it's too much. Maybe let's make it 100. Yeah, now it's working properly, right? So here you can see now we are snapped to a grid, right? So that location is somewhat more precise, right? So actually in RTS game, this grid snapping is used to somewhat organize your building placements, right? Because since we have this grid snap, the buildings that you are placing on your level, it will be somewhat aligned, right? Somewhat horizontally aligned with each other. So that's why this grid snapping exists in RTS games, right? But yeah, you can actually tweak these values based on your need. But I think this 100 will be quite okay with our RTS game. Okay, so that's how we can do grid snapping, and in the next tutorial we'll see how we can optimize this placement and maybe some level design stuffs as well. So thank you. I'll see you there.